Assalamualaikum warahmatullahi wabarakatuh. Firstly, my name is Ahmad Ibrahim bin Azhari. My metric number is CE1901C1. So as for today, I would like to present about my group project, which is digital filter in digital signal processing. So I'm going to the introduction. Okay, as for the introduction, digital signal processing is the mathematical manipulation of an information signal. This DSP manipulates different types of signal with the intention of filtering, measuring, compressing, and producing analog signal. It is a system that performs mathematical operation on a sample discrete time signal to reduce or enhance a certain aspect of that signal. With this, the ideal frequency amplitude characteristic can be achieved. Besides, filter can be used to shape the signal spectrum in a desired way or to perform mathematical operations such as differentiation and integration. Then, a digital filter is characteristic by its transfer function, equivalently its different equation. MATLAB and digital filter help us analyze signal from range of data sources. It is used signal processing technique to explore and analyze time series data. It provides a unified workflow for the development of embedded system and streaming application. At last, MATLAB can help us acquire, measure, and analyze signal from many sources. So, for the objective, firstly, our objective is to understand digital signal processing subject with specific to digital filter that is learned during semester. Second, it is to increase student knowledge about MATLAB programming software to produce results that are required by the question given. And then students know how to decide the type of filter needed based on the questions. After that, students can apply their theoretical learning to implement and design the appropriate solution to the given problems. At last, it is to develop student critical thinking in problem solving within their group. Thank you.
Okay, Assalamualaikum and good morning. My name is Imran bin Muhammad Ghazali. Metric number CE190118, and I'm going to explain about the methodology of our group project. Okay, this is our group methodology. Okay, for the theory applied, we use the discrete Fourier transform (DST), which have a Fourier transformation is used to decompose time series signals into frequency components, each having an amplitude and phase. Next, we use a fast Fourier transform (FFT), which is a computationally efficient algorithm to obtain the FT that use fewer multiplication. Next, we use Z transform. The analysis of separate signal is inexplained can be complicated due to it having infinite long polynomials due to characteristic infinite number of poles and zeros in it. Z transform is used to reduce the pole and zeros to a finite number in Z plane. Okay, for the tools used, we use MATLAB simulink. Okay, this is the flowchart for the project. First, we start and then we construct the coding at MATLAB to determine the spectrum of signals. Next, we process the data in MATLAB simulation. After that, we obtain the signal spectrum and then we observe and analyze the result to choose the appropriate filters. And that's all for the methodology. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq Besa and I'll be presenting for the simulation part of this presentation. Okay, so for the first question, we will need to find from the given data a signal that needs to be plotted to determine its spectrum, magnitude, and also the phase amplitude. We will be using the Fourier transform, discrete Fourier transform calculation technique. Okay, so for in the coding of the modeling work in the melee environment, so we have define the fs, which is the sample. So we have 30 data that were given. So we will need to input the 30 data into the x definition, and then we can do the plotting using the figure command, and then we can plot the signal of xn, that is time versus the amplitude. Okay, after that we will be calculating using the Fourier transform for the magnitude and also the phase. Okay, so we will use the same command, the figure, and then we will need to plot for the magnitude, which is for the frequency versus amplitude, and then for the phase, for the frequency versus phase. Okay, so this is the result of the first question simulation. Okay, on to question 2. Okay, for question 2, we will need to be applying a filter using some digital processing technique of filter design to implement to filter the signal that we just have in question 1 by using the infinite impulse response. Okay, so the filter design equation has already been given by the question. So we follow the same procedure of defining the signals and also the data, and then we will need to define the h, which is the equation for the filter signal that were given, and we need to use the y equals to filter and to input the data into the filter, the data of the signal spectrum into the filter. So, and then finally we will plot the filtered signal that we have just got into the appropriate figures. Okay, so the resulting simulation output will be shown like this. So this is the filtered signal that we have from the previous question, which was question 1. Okay, now for the question 3. Okay, so for the final simulation of the question, which is for the question 3, so we need to find the output of the filtered signal that we have just got from the result of question 2. So we will need to use the discrete Fourier transform calculation technique. So the coding for the filtered signal is the same as from question 2. So after we obtain the result of the filtered signal, we can use the calculate of the Fourier transform modeling work to calculate the output signal. So we do the coding like this, just as the previous question 1, and then the output result will be like this. So we will obtain the result of the signal. This is the result of the signal, which is the amplitude versus the time. Okay.
Assalamualaikum. My name is Muhammad Afiqimi bin Muhammad Shukri, CE190142. For my part, I will explain about the type of filter based on the result. This is low pass filter. Low pass filter is a filter that pass signal with a lower frequency beyond the select cutoff frequency. Low pass filter is used to filter the last frequency from the output graph, as you can see on the left. The result of the signal before filter and after filter, it can be concluded that the third frequency has been filtered, which is the third frequency is this frequency. This is before, this is after. For high pass filter is an electronic filter that passes signal with a higher frequency than a certain cutoff frequency. It will alternate the signal with a lower frequency than the cutoff frequency. To simplify the operation, the high pass filter in the first frequency. So the high pass filter is filtered. The high pass filter the signal is over here. This is the first frequency on the green dots. The band pass filter. Band pass filter is a device that passes frequency within a certain range and rejects frequency outside that range. To simplify operation, the band pass filter will filter the left and the right frequency. So this is the frequency. This is the left and the right frequency. Means before the frequency and after the frequency. This is the result of the before filtered and this is after filtered. You can see the difference. So this is not filter. A notch filter or band stop filter or band rejection filter is a filter that passes most frequency altered, but alternates those in a specific range to very low level. The process is opposite from the band pass filter. A notch filter is a band stop filter with a narrow stop band.
higher Q factor. To simplify the operation, the notch filter will filter the middle frequency in this project. So the notch filter will filter the signal in this between the frequency 1 and 2, which is in this middle. You can see over here in the green box. Okay. So for the discussion, a signal needs to be plotted to determine its spectral magnitude and phase signal by using discrete Fourier signal (DFT) calculate techniques. The coding needs to be constructed along with by inserting the specific data which has been given to obtain the signal result of spectral magnitude and phase signal. The filter design is implemented to filter signal by using infinite impulse response (IIR) filter design with the given filter equation, which is the Hz. In the filtering process, the construct coding is substituted into filter equation and obtain Hz to obtain the Yn output signal result. So to obtain the filter output signal, the previous signal need to be converted into spectrum magnitude and phase signal. The phase result is converted by using DFT to in the coding construction. So then 4 filter is involved have been identified in this simulation: the low pass filter, high pass filter, band pass filter, and notch filter or band stop filter. These 4 filters have been analyzed and can be compared to identify its difference based on the first signal of spectrum magnitude and phase with the final signal of spectrum magnitude and phase. You can see the difference when the signal before it filtered and after it filtered. As for the conclusion, it shown that the signal is successfully filtered and both signal from the initial signal and final signal are completely different because it's gone through the filtering process. The final result is by comparing both signal amplitude plotting, and it showed the signal are much smoother than the signal before filtering process. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Karina Syara binti Zaludin, matrix number CE190188, and today I would like to talk about the conclusion and the reference for our project. So, I will talk about the conclusion of our project. As a conclusion, this project has been able to help the student understand and gain more knowledge about how does digital filters work. Digital filters have been used widely in almost area of digital signal processing. One of the reasons is because it can perform mathematical operations on a sample discrete time signal to reduce or enhance certain aspect of signal. Next, the student able to increase ability to use MATLAB programming software. MATLAB programming software is an application that allows us to acquire, measure, and analyze signal from many sources. As you can see in result or analysis part, the signal have been generated successfully by using this software. To get the signal, the student use a right coding that suit with the question. Other than that, the student able to decide the type of filter that needed to be used in each part of the question. The filter that have been used is low pass filter, high pass filter, band pass filter, and notch filter. These 4 types of filter have different function and have been compared based on the first signal of magnitude, spectrum, and phase with the last signal of magnitude, spectrum, and phase. Furthermore, the student gain more knowledge on how to implement and design an appropriate solutions to the given problems. Before the simulation have been done, the student do a revision first on how to solve the problem. Then, the student choose a proper theoretical knowledge and solving the question based on their theoretical to get the result. The theories that have been learned in the classes play a very major role which help the student able to finish this project as it teach the student on how to solve the problem. As a result, the student able to apply the fundamental theories that have been learned to complete this project. Next, I will show you the reference of our project. So, this is a part of a website that has been used by us to gain more knowledge and search for information which help us to solve this project. So that's all from us. Thank you.